Okay, so as we work with more conical sections, we are we are going to work with the ellipse, and we've done a little limited interaction with the ellipse as you've gone through geometry in previous Algebra 1. But what we're looking for, or what we're looking at, is the general shape here. You notice we have we're going to have a horizontal ellipse, and it is a bit elongated on the horizon. So we have a oval which is stretched out across the horizon, and then we have a vertical ellipse which is a more up and down shape. But it's just its orientation, whether it sits vertically or horizontally. All the rest of the characteristics are generally the same. So we're looking at the major axis of an ellipse is its longest axis, and on that longest axis you'll see the vertices, which will touch your ellipse, and then of course your focus, which will be just inside the ellipse. Then you'll have your minor axis, and that is going to be going from the ellipse along the it'll give you your co-vertex, and that co-vertex is going to be the points from ellipse end to end. And of course you'll have your center. Just some of the names, the nomenclature of what you'll get out of the equation. And looking at the horizontal ellipse, your standard equation here, you'll notice that we have a fraction. It's x squared over a squared plus y squared over b squared. And what that's really identifying here is A is going to be the length from the center to your vertex, and that is going to be larger than B. Again, that's how you get your major axis. So your major axis, the length of A is going to be greater than the length of B. This being the length of B, this being the length of B, and this being the length of A. Then we're going to see your vertices, of course, would be at each end of the A. Your co-vertices would be at each end of the B. And then your foci, we'll learn more about the foci later on, but that's how you're going to be able to identify these points. And let's see here, your foci right here for later. And so I just wanted to give you these general characteristics as we go forth into the rest of the explanations. Now we have covered much of the vocabulary here just in the previous slide, but again, just for your information, here's my horizontal ellipse, and you'll notice that a squared is under the x-axis. A, remember, was going to be the longer axis, and then for the vertical axis, the a squared is under the y squared, which is going to be a vertical axis because a vertical ellipse because it is stretched out vertically. So that's some of the things that you can see characteristically when you're doing these equations. You'll also know that it has an addition sign, and it is equal to 1. That is the standard form. So as we go forward here, write the equation of an ellipse. Let's see here, in the standard form of an ellipse centered at the origin with vertex 0, 5 and co-vertex 2, 0. Well, if I look at my vertex, the y-axis is farther away from the origin, right, as we start the origin. My this is going to be 5 and vertex, so then the negative 5. That is going to be this vertex right here, and then I'm going to have 2 and negative 2. Well, that means that it looks like it is going to be stretched vertically, and of course then A is going to be, this is going to be my A, and this is going to be my B. So as we build that function or that equation, so we will have we're going to have x squared over b squared plus y squared over a squared is going to be equal to 1. And we've seen here that our b is going to be equal to 2, and our a is going to be equal to 5. So we can just put that information in here. And then we get x squared over 2 squared plus y squared over 5 squared equals 1. Or when we simplify it, we're going to get x squared plus 4 plus y squared, x squared over 4 plus y squared over 25 equals 1, and that is going to be the form of the equation. And again, remembering since 5 is farther away from the origin than 2, my a was 5 and then my b was 2. Let's see here, looking at the next example, finding the focus of an ellipse, or the foci, plural for focus. What are the coordinates of the foci of the ellipse this? Okay, graph that ellipse. Now we do want to get it into standard form, and standard form was equal to 1. So in order to get this equation equal to 1, I would divide both sides by 3,600. And let's see here, I better do this a little bit more definitively. I'm going to divide all my terms by 3,600, and we know that that's going to simplify down to 1, and then this is going to simplify, this expression right here is going to simplify down to y squared over 36, and then my next one will simplify down to simply x squared over 100. There we go. That's going to be, right now we're at the standard form of the equation, x squared over 100 plus y squared over 36 equals 1. But they have asked us to do what? Well, is it going to be a horizontal or vertical ellipse? Well, since I have a greater value underneath x squared, that means a squared is 100, and therefore a is 10. And here I'm going to have b squared is 36, plus or minus, and then b is therefore plus or minus 6. And looking here, so the greater axis is going to be my x-axis, and it's looking for my foci. And it doesn't give us our foci yet, but we're going to learn quickly here that in order to calculate the foci is going to be c squared. Remember, the foci was designated as c, equals a squared minus b squared. And we know that a squared, we've already said, is going to be 100 minus b squared is going to be 36. And c squared is going to equal 64, or the square root of c squared equals the square root of 64, which c equals plus or minus 8. All right, and if we're going to go ahead and graph this, let's get an ordered pair, coordinate plane. Okay, not a beautiful or perfect ellipse, but we've gone and we've identified the our vertex and covertex. So we are sitting at 5, 0, negative 5, 0, and of course 6, 0, negative 6, 0, and I take that back, that's not 5, 0, negative 5, 0. We, of course, graphed by values of 2, so that is actually, that is going to actually be negative 10 and 10, 0. So there we go, we've graphed our ellipse, we've identified what our foci were. Our foci were going to be, this would be negative 8, 0, and then 8, 0. And I believe that is all the information that they asked us to come up with. All right, so it says this room with an elliptical ceiling fan forms a whispering gallery, okay, and thanks to the reflective property of the ellipse, a whispered message at the focus at the focus can be heard clearly by someone standing across the room at the other focus. If the elliptical ceiling has a major axis of 120 feet and a minor axis of 72 feet, how far apart are the foci? Let me get a picture in here. Okay, if you're having a problem picturing what we were just talking about, you have two gentlemen standing at a focus, and we are trying to figure out how far apart are the foci. Let's see. Okay, I've gone and identified some labeling, some A's and B's, and then of course our foci are going to be our C's. But what we do know is that the distance from the foci, or let's see here, the distance from here to here is going to be A, and the distance from here to here is going to be B. Therefore, we know that this distance over here is also A. So we know that 2A is going to be equal to the major axes, which we've already identified as 120 feet. Therefore, divide by 2. 1A is going to be equal to 60 feet. B is going to be our minor axes, and we said that the minor axis is 72 feet. So we know that B is going to be equal to 36 feet. Let's see here. So as we look at this, of course, we knew that this entire length right here was going to be 36, and then we knew that this entire length right here was going to be 120. Let's see here, going forward. What else do I need to know? Well, the foci. We figured the foci before were c squared equals a squared minus b squared, or c is going to equal the square root of a squared minus b squared. And we know that a is going to be 60 squared, or a is 60, so it'll be 60 squared minus b was 36, and we'll square that. So c is going to be equal to, and the square root of 2,304 is going to be 48. So it says how far apart are they? Well, it would not be just 48, it would be 2c is equal to the length, and how far apart they are. Well, we know then that would be 2 times 48, or 96, and we talked earlier that it is in feet, so it would be 96 feet apart. Looking at this next portion of the example, it says how far apart are the foci of an ellipse with a major axis of 26 feet and a minor axis of 10. Major axis of 10, or minor axis of 10, a major axis of 36, and it wants to know how far apart are my foci. Well, we just said that, well, 2a is 26, so a is going to be 13, and 2b is 10, therefore b is going to be equal to 5. Now we can use our formula. The c is equal to the square root of a squared minus b squared, or c is equal to the square root of 13 squared minus 5 squared. Simplify that, and we're going to get 144, or c is going to be equal to 12. If c is equal to 12, then what are we looking for? This distance would be 2 times 12, or 24. So 2 times c equals 2 times 12, which equals, probably not a very good color, 24 feet apart. Let's see, as we are wrapping up our examples for this section, what are in the standard form of equation of an ellipse with a foci of this and a co-vertices of this? Well, we know this. right? Says my foci are at square root of 17. And this is along the square root of 17 is going to be your y value. So I can go, okay, what do I need to know here? I know, if you think about it, the square root of 17 is, you know, just a little bit over 4, okay? And then the covertices is going to, on x is, so let's see here, x, -6, and +6, and then we know that for the square root, the vertices is somewhere 1, 2, 3, 4, just above 4. This is going to be C. So there are my foci, then my covertices, and now I'm wanting to figure out where my vertices are at. Well, if I know that C is equal to a squared minus b squared, there you go, then C, we just said, is the square root of 17. And what do I want to do to get rid of this radical? Well, if I turn around and I square both sides, that will get rid of my radicals, and then this becomes 17 is equal to a squared minus b squared. And what do we know? Well, goodness, we know that b is going to be 6. So I have 17 is equal to a squared minus 6 squared. And we can just go ahead and say that 6 squared is 36. Go ahead and add 36 to both sides so we can do some solving. And then I have a squared is equal to 53, and then the square root, or a, is going to be equal to the square root of 53, which is going to be somewhere out here, square root of 53, negative square root of 53, and there you go, connecting my covertices and my vertices. So a is equal to the square root of 53. Standard form of the equation, well, I have x squared, and because we've already said that right up here was our b value, and then y squared is going to be, hey, b squared is equal to the square root of 53 squared, so 53 equals 1, and there is the standard form of my equation.